membrane bioreactor. The membrane bioreactor process, MBR, has earned an industry-wide reputation for being a model of sustainability as it saves both energy and precious water resources. Added to the Tri-City Water Resource Recovery Facility in 2011, the MBR's advantages is that it can treat wastewater using a much smaller footprint. Thus, more water can be treated in a smaller space. After primary treatment, some of the effluent is diverted into the MBR rather than being treated conventionally. This is a treatment process that uses hollow fiber membranes to treat their wastewater and remove contaminants. The MBR process is used simultaneously with the conventional process in the Tri-City plant and typically treats 4 million gallons per day, with the capability to treat up to 10 million gallons per day during peak flow. The amount treated in the membrane process is determined by the plant operators and depends on the conditions. Before being sent to the membrane bioreactor, the diverted water is further screened in the fine screening building. The fine screens are made of panels perforated with small 2-millimeter holes that remove the finer material that may otherwise cause damage or undue wear on the equipment downstream. The removed material is sent to the local landfill. The wastewater is sent from the fine screen building to the MBR Aeration Basin. This is similar to the aeration basin used in the conventional process. Oxygen is blown into the basin, promoting oxygen-loving aerobic microbes. These microbes eat the organic waste, breaking it down into carbon dioxide and clean water. To avoid spreading unpleasant odors, air from the aeration basin is sent through a biological odor control tower, which mixes nutrient-rich water, odor-neutralizing microbes, filters, and gases from the aeration basin. After the aeration basin, the water flows into the membrane bioreactor for membrane filtration. This consists of a large, deep tank filled with cassettes holding membranes shaped into long strands. The strands are hollow on the inside. Each membrane train has 131,000 square feet of surface covered in thousands of tiny pores. There is a vacuum pressure at each end of the fiber that draws water through the pores into the strand, resulting in extremely pure water. Scour air is pumped into the tanks to keep solids from sticking to the outside of the strands, and the water flows through the tank and is sent back to the aeration basin, with some of the solids being sent to the digesters. The water that has been drawn through the membrane fibers is pumped into the UV building, where it is exposed to powerful UV lights. The UV lights sterilize any remaining microbes in the water, thus disinfecting it.